In today's lesson, we are going to learn about inequalities and regions. Students, we live in an unbalanced world. Some people are richer compared to others. Some students have access to better schools compared to others. Sincerely speaking, some students go in schools where there is no breakfast, that is number one. Two, where there is no lunch. And to make more matters worse, they have to sit under trees for a lesson. And at the end of the year, they have to sit, for example, PLE with those learners who went to good schools. At the end of 4 years, they have to sit UCE with those learners who went in schools where there's a library, they sit under flats, ACs, they have 4 meals a day, they have all the facilities that can enable them to prosper in their academics. But those are imbalances, because at the end of 4 years, they have to sit for the same paper. Is that true? Those are imbalances. On another hand, some people have better paying jobs. In fact, you may move along Kampala and you wonder whether all the vehicles in Kampala are supposed to be in the hands of the few, neglecting the majority. Even you fail to identify where you park a bicycle, just a mere bicycle. Someone is parking V8, but for you, you are yearning to park a bicycle. Those are inequalities. Similarly, in mathematics, 0 is less than 1. That's why you have a saying, 1 is better than 0. That is an imbalance. We expect, since all the numbers lie on the same number line, they are supposed to be equal. But you say 0 is less than 1, or 1 is better than 0. Those are imbalances. So, in this topic, we are going to learn to represent inequalities on a Cartesian plane and solve problems involving inequalities. Are we ready for inequalities? Yes. Summary. We have our summary. 1. The following symbols are used when dealing with inequalities. The first symbol is less than. Yes. If we have two numbers, for example, 2 and 4, we shall say 2 is less than a 4. Symbol number 2 is greater than. So if we have our two numbers, for example, 4 and 2, we shall say 4 is greater than a 2. What do we observe? The tip of the inequality symbol faces the smaller value, and the opening of the inequality always faces the bigger value. We have other inequality symbols, for example, less than or equal to, comma, greater than or equal to, and not equal to. That is note number 1. Note number 2, inequalities involving less than, comma, greater than, comma, or not equal to are referred to as strict inequalities. What do we mean? If I have two numbers, for example 2 and 6, we shall say 2 is strictly less than 6. 2 is strictly less than a 6. And if we have two numbers 2 and 6, we cannot say that 2 is equal to 6. That is not real. Therefore, we say 2 is not equal to a 6. And we are saying that while inequalities that have, for example, less than or equal to or greater than or equal to are called bounded inequalities. Is that okay? Bounded or not strict inequalities. We can have a situation where we have two boys, that is Brian, and another boy is Sekati. We can say Brian is slightly greater than or equal to Sekati. In fact, if you compare the heads, you can fail to identify who has the bigger head and who has the smaller what? The smaller head. Therefore, we say Brian is slightly greater than or equal to. Therefore, two conditions can hold. Brian can be greater than in terms of the head, or Brian can be equal to in terms of the what? Of the head. That was note number 2. Note number 3. The inequality symbol reverses when you multiply or divide an inequality by a negative number. I'm repeating. The inequality symbol reverses when you multiply or divide an inequality by a negative number. What do I mean? We can have two numbers, for example, -4 and 5. Yes? If they tell us to insert an inequality symbol, we shall always say that -4 is less than a 5. Is that true? But if we divide both sides with a -1, yes, we shall realize that 4 will be greater than a 5, which is a negative. Is that okay? Therefore, whenever you divide an inequality by a negative, make sure that the sign reverses. That is note number 2. Note number 3. To represent an inequality on the number line, comma, we use an open circle for less than or greater than. I'm repeating. To represent an inequality on a number line, comma, we use an open circle. When I talk about an open circle, I talk about that. You draw a circle and you don't shade it. And this one is what we call an open circle. And in case we have less than or equal to or greater than or equal to, we use a closed circle. That one, we draw a circle and then we shade it. That was note number 4. Note number 5. Integers in the range of given inequality are called integral values. What do we mean? If we have x greater than a 4, what are the possible values of x that are greater than 4? What are those possible values? We have a 5, a 6, 7, 8, 9, 10, and other values. Now we are saying integers in the range of a given inequality, for example x greater than 2, are called integral values. These ones 5, 6, 7, 8, 9, 10 are called integral values. Example number 1. Hope we are making some smaller notes because they will be of use in the future. But if you put them down, you will always refer to them. Brian, clean the board. Are you cleaning? Yes, teacher. Try to hurry. Yes, teacher. Example number 1. Find the integral values find the integral values of x in the following inequalities. Roman numeral 1. The first inequality is x is greater than a 2. So what are the integral values of x greater than 2? Remember, x is strictly greater than 2. So they want the integral values of x that are strictly greater than 2. What are those values? We have a 3, 4, 5, 6, 7, 8. Those are integral values of x greater than a 2. Roman numeral 2. X less than a 2. They want you to find the integral values of x less than what? A 2. Remember, they are telling us that x is strictly less than a what? A 2. Therefore, we shall say x is equal to, we shall start with 1, we go to 0, we go to -1, -2, -3, and -4. Those are the integral values of x less than a 2. Roman numeral 3. X greater than or equal to a 2. Are we seeing that? Implying that this inequality has two sides. One, x is greater than 2 and x is equal to what? 2. Therefore, the integral values of x that are greater than or equal to 2, we shall start with 2 itself. We go to 3, we go to 4, 5, 6, 7, 8, and the other values. Roman numeral 4. Find the integral values of x less than or equal to a 2. What are the integral values of x less than or equal to 2? Remember, in that inequality, x is equal to 2 is inclusive. Therefore, we shall start from above. We start from a 2. We go to a 1. We go to 0. We go to negative 1, negative 2, negative 3, negative 4, and negative what? 5. Is that okay? So this is your trial. Please copy it down. Trial. Copy it down. 1. Find the integral values of x for the following inequalities. Roman numeral 1. X is greater than negative 7. Roman numeral 2. X is greater than or equal to 0. Roman numeral 3. X is less than negative 4. Roman numeral 4. X is less than or equal to a 1. Roman numeral 5. Negative 1 is less than x, but x itself is less than or equal to a 3. Roman numeral 6. Negative 7 is less than or equal to x, but x is as well less than a 4. Roman numeral 7. Negative 6 is less than or equal to x, but x itself is less than or equal to a 5. Therefore, you are going to list for me all the integral values of x in those inequalities. I'm expecting the solutions by tomorrow. Please copy the trial questions down. As Brian is cleaning the board. Hope we have copied them down. Okay, the next item is solving inequalities and represent the solution on the number line. Solve inequalities and represent the solution on the number line. Example number 1. We have 5x plus 7 is less than 3 into x plus 1. Remember, they are telling us solve inequalities and represent the solution on the number line. So Roman numeral 1, 5x plus 7 is less than 3 into x plus 1. What are we going to do? First of all, we are going to first open the brackets, and that is 5x plus 7 is less than, what is 3 times x? That is 3x, plus, what is 3 times 1? That is a 3. From there, we are going to collect like terms. What do I mean? I'm going to collect variables on the left hand side and the constants on the right hand side. This is what I mean. 3 is going to be taken on the left and 7 is going to be carried to the what? To the right. So I'll have 5x. Remember, 3x is positive. Therefore, when it crosses the inequality symbol is going to become what? Negative, and that is 3x is less than. Remember, 7 is positive, and when it crosses the inequality symbol, it is going to become a what? A negative. Therefore, it is 3 minus 7. I'm having a question. 5x minus 3x, what do we get? That is 2x, and everything is less than, what is 3 minus 7? That is a negative what? 4. We are going to divide both sides by 2, and we shall have x is less than negative 2. Remember, they are telling us solve inequalities and represent the solution on the number line. Therefore, we have to draw the number line. That is our number line. We shall have 0, negative 1, negative 2, negative 3, negative 4, negative 5. But x is less than negative 2. It implies that 2, which is a negative, is not inclusive. Therefore, we shall draw an open circle and we draw an arrow going to the what? Towards the negative. And that is x is less than negative 2. Is that okay? Example number 2. Example number 2. We have example number 2. It is 7 open brackets 2 minus x plus 1 is either less than or equal to 2 into 2x minus 9. So we have to first open the brackets, and if we base on the left hand side, we shall have 7 times 2, that is 14, minus 7 times negative x, that is negative 7x, plus 1, and everything is less than or equal to, what is 2 times 2x? That is 4x, minus, what is 2 times negative 9? That is negative 18. So 14 plus 5, that is 15, minus 7x, everything is either less than or equal to 4x minus 18. We are going to collect like terms. So unknowns are going to go towards the right, the left, and the constants are going to move towards the what? The right. So we shall have 15 minus 15, yes, minus 7x minus 4x is less than or equal to 4x minus 4x minus 18 minus 15. This 15 will die with that, and 4x will die with negative 4x. What is negative 7x minus 4x? That is negative 11x, and everything is either less than or equal to negative 33. Is that okay? So we are going to divide both sides by negative 11, and we say that when we are dividing with a negative, the inequality symbol changes. Therefore, negative 11x divided by negative 11 is either greater than or equal to negative 33 out of negative 11. By negative 11, 1, by negative 11, 1. Therefore, we shall have x greater than or equal to, by negative 11, 1, by negative 11, that is a 3. Remember, they are telling us solve the inequalities and represent the solution on the number line. And if we are going to represent the solution on the number line, we shall have, this is 2, 3, 4, 5, 6, 7. And x is equal to 3 is inclusive. Therefore, we are going to use a closed circle like that, and we move towards the right like that. So this is x is greater than or equal to a 3. Roman numeral 3. We have 5x plus 3 is greater than negative 11 minus 2x. Let us copy that one in our books. Another example, we have x divided by 4 plus 3 is greater than or equal to 1 plus x out of a what? A 2. So we are going to find the LCM. So what is the LCM of 4 and 1? That is a 4. 4 divided by 4, that is 1. 1 times x, that is x, plus 4 divided by 1, that is a 4, times 3, that is a what? 12. And everything is greater than or equal to, what is the LCM? The LCM is a 4. Is that okay? 4 divided by 1, that is a 4, times 1, that is a 4, plus 4 divided by 2, that is a 2, times x, we get 2x. So we are going to multiply both sides by 4. We multiply both sides by 4. And by 4, 1, by 4, 1, by 4, 1, by 4, 1, we shall have x plus 12 is either greater than or equal to 4 plus 2x. What are we going to do? We are going to collect like terms, implying that we shall have x. I'm going to transfer 2x towards the left. Since it is a positive, it is going to acquire a negative sign, so that is negative 2x, and everything is greater than or equal to 12 is going to be transferred towards the right. Therefore, that is 4. Since it is a positive, when it crosses the inequality symbol, it is going to become a what? A negative. So what is x minus 2x? That is negative x. And everything is greater than or equal to, what is 4 minus 12? We get negative what? 8. So we are going to divide both sides by negative 1. And we say that when we are dividing with a negative, the sign of the inequality changes. And we shall have negative x divided by negative 1 less than or equal to negative 8 divided by negative 1. Negative dies away with the negative, and we shall have x is less than or equal to 8. Remember, they are telling us to represent the inequality on the number line. So we shall draw our number line. We write there the integral values, that is 6, 7, 8, 9, 10, 11, 12. Remember, they are telling us that x is less than or equal to 8, implying that 8 is inclusive. Is that okay? And we move towards the what? The left. And that is x is less than 8. Another example, 7 is greater than or equal to 4 minus 3x, and 4 minus 3x is greater than a negative 5. So what are we going to do? First of all, we are going to make x the subject. How? We are going to subtract 4 from all the 3 sides. That is 7 minus 4 is greater than or equal to 4 minus 4 minus 3x, and everything is going to be greater than negative 5 minus a 4. Students, I've subtracted a 4 here, a 4 there, and a 4 on negative 5. What is 7 minus 4? That is a 3. And everything is greater than or equal to, what is 4 minus 4? That is a 0. And we are going to remain with negative 3x. and everything is greater than negative 9. Now we have to leave x independent. Is that okay? So we are going to divide through by a negative 3. And we shall have 3 divided by negative 3. This inequality symbol is going to reverse, that is less than or equal to. This is negative 3x divided by negative 3. Since we are dividing with a negative, so this inequality symbol is going to reverse, and that is negative 9 divided by negative 3. By negative 3, 1, by negative 3, negative 1, so we shall have negative 1 is less than or equal to, by negative 3, 1, by negative 3, 1, so that is x, and everything is less than by negative 3, 1, by negative 3, that is a 3. So our region is negative 1 is less than or equal to x, but x is less than a 3. If they tell us to state the integral values, negative 1 is inclusive. Is that okay? So we shall say x is equal to negative 1 is inclusive, 0 is there, 1 is there, 2 is there, but 3 is not what? Inclusive, because of this strict inequality symbol. And remember, they told us to represent everything on the number line. So that is negative 2, negative 1, 0, 1, 2, 3, and 4. Remember, negative 1 is inclusive, therefore we draw a closed circle. And 3 is not inclusive. We draw an open circle. From there, we connect the two circles, and we shall say that this is negative 1 less than or equal to x, but x is less than a 3. Hope we are following, students. Yes, that is beautiful. Another example, using a number line, comma, find the integral values of x which satisfy the sets below. Using a number line, comma, find the integral values of x which satisfy the sets below. The first set is 5, minus 3x is greater than negative 7, intersecting with the set x minus 6 is less than or equal to 3x minus 4. Is that okay? They are telling us using a number line, comma, find the integral values of x which satisfy the following set. The first set is 5 minus 3x is greater than negative 7, intersecting with x minus 6 is less than or equal to 3x minus what? 3. So we are going to first deal with this set. And we shall say 5 minus 3x is greater than negative 7. So we collect like terms. What does that mean? We are going to carry 5 to the right. And that is negative 3x is greater than negative 7 minus what? 5. Implying that negative 3x is greater than, what is negative 7 minus 5? Yes, that is negative what? 12. We are going to divide both sides by negative 3. Therefore, we shall have negative 3x divided by negative 3. Remember we said, while dividing inequalities with a negative, the inequality symbol does what? Changes. And that is negative 12 out of negative 3. By negative 3, 1. By negative 3, 1. So we shall have x is less than negative 12 divided by negative 3. That is a 4. That is set number 1. Set number 2, we have x minus 6 less than or equal to 3x minus 4. So we are going to collect like terms, implying that we are going to carry negative 6 to the right and 3x to the left. And that is x minus 3x is less than or equal to negative 4 plus what? 6. What is x minus 3x? That is negative 2x, and everything is less than or equal to a 2. We divide both sides by negative 2, and that is negative 2x divided by negative 2 greater than or equal to 2 divided by negative 2. By negative 2, 1, by negative 2, 1. So we shall have x is greater than or equal to, by negative 2, negative 1 by negative 2, that is a 1. Implying that they want us to find the regions of x less than 4 intersecting with x greater than or equal to negative 1. And if we draw our number line, we shall have, this is negative 2, this is a 1 negative, sorry. Let me draw it here. This is a number line. So we have negative 1, 0, 1, 2, 3, and 4. Remember, they are telling us that x is less than 4. That is the first inequality. So this is 4. But they are telling us that x is less than 4. Therefore, we move towards the what? The left. 2, they are as well telling us that x is either greater than or equal to negative 1. implying that negative 1 is what? Inclusive. Like that. Here we shade the circle and we move towards the what? The right. Are we okay? Now, they want us to find this region or this inequality where the two inequalities meet. And this inequality is, remember this one is a closed circle, so we shall have negative 1 less than x, less than or equal to, because it is closed, x, and then x is less than a what? A 4. What are those integral values? So we shall say the intersection of two sets is x is equal to, we list the values, negative 1 is inclusive, 0 is inclusive, 1 is inclusive, 2 is inclusive, 3 is inclusive, but 4 is not inclusive. Trial questions. Find all integral values of x which satisfy the following inequality. This is the first inequality. Inequality number 1. 5x plus 7 out of 4 is less than or equal to 3x plus 5 divided by 2 less than x plus 11 out of a 3. That is trial question Roman numeral 1. Trial question Roman numeral 2. Find all positive integral values of x which satisfy the inequalities. That is x divided by 4 minus 3 is less than or equal to x plus 2 less than or equal to 21 minus 2x. That is trial question number 2. Trial question number 3. Given that negative 1 is less than or equal to x, but x is less than 4, find the values of a and b. Find the values of a and b for which a is less than or equal to 2x plus 3, but 2x plus 3 is less than a b. Roman numeral 4. Find the range of values. Find the range of values of x which satisfy the following inequalities. Find the range of values of y. Find the range of values of x which satisfy the following inequalities. That is x minus a 4 less than or equal to 3x plus 2 less than 2 into x plus a 5. And finally, given that p is equal to, that is set p is equal to x such that x is between 4 and 2, and set Q is such that x is a set of values ranging from -2 less than x less than a 5 full stop. Represent P intersection Q on a number line and state P intersection Q. I'm repeating. Given that P is a set of values of x such that x is between -4 and 2, but -4 is inclusive, and set Q is a set of values of x such that x is between -2 and 5, full stop. Represent P intersection Q on the number line, full stop. State P intersection Q. Thank you for watching. Don't forget to subscribe, like and share the video for more about mathematics.